To my latest video. This one's going to be on stoichiometry, and this video is focused on students who have already mastered a lot of the fundamental concepts of unit conversion using moles. I'm assuming that you are already pretty good at going from moles of a substance to grams or vice versa, and also molecules of a substance to moles and vice versa. And then finally, molecules to grams, and also the other way around. If you haven't mastered these three concepts yet, you should go back and review a previous video or come see me for help, because this will be fundamental in your success with stoichiometry. So stoichiometry, besides being a very difficult word to spell, is really looking at chemical reactions, and it's looking at them kind of like recipes. In chemical reactions, we already know quite a bit from our year, and we know that this little letter here to the bottom right of these substances indicates the phase. We know that these little numbers here that are actually inside the compounds represent the amount of the element to their left that's actually being added to the substance. So this NH3 has 3 hydrogens, and this H2 has 2 hydrogens, and that's the compound or the molecule. But we haven't really focused a ton on these numbers out front. And in balancing, we've gone over this. If we've done that yet, I'm not sure where, if we're going to be doing that first this year, but I'm assuming we will. So these are called molar coefficients, and I can spell that out for you. So they are molar coefficients. And just testing my spelling today. So molar coefficients, and what they tell us is they tell us the amount in which our substances combine, or reactants combine, to make a product. And stoichiometry is nothing more than asking questions about, okay, well, what if we had 8 moles of NH3, and how many moles of H2 do we need? And that's at kind of a basic level. It's just saying, okay, well, how much of this do we need to produce a certain amount of this? Or, if I have a certain amount of N2, how much hydrogen will I need to react with it? And to do that, we're going to be utilizing these molar coefficients. Now, if we don't see a molar coefficient in front of our compound, for example, N2 doesn't have anything, we always assume a value of 1. And these will help us to answer any questions stoichiometry has to throw at us. Okay, before we move on, just as we created conversion factors for all 3 of these conversions up here, we're going to be using those molar coefficients to make a conversion factor. And that's going to be a mole of one substance, I'll say a mole of X, is equal to a mole of another substance. So mole X equals mole Y. And we'll see how that comes into the picture in this question. Whoa, here we go. Okay. So we could have a question such as this, and it's asking us, well, how many moles of hydrogen, so how many moles of hydrogen are needed to completely react with 2 moles of nitrogen? So notice it didn't really ask us anything about NH3, so for this sake and for this question, we can kind of just ignore this NH3. We don't really have to look at it at all, which is kind of nice. It's always nice to be able to simplify things. So in order to solve this question, well, it's saying how many moles of hydrogen. So we want to be organized here. So I'm going to say, okay, well, above hydrogen, I'm going to put a question mark and then an M for I'm looking for moles, are needed to react with 2 moles of nitrogen. So I'm going to say, okay, well, I have 2 moles of this. So I start with 2 moles of nitrogen, and I want to get 2 moles of hydrogen. So notice I only have moles in my question. I don't actually have grams or molecules. So if I look back at my possible conversion factors, if I cannot mess this up, possible conversion factors, well, I have moles to moles. So this is the new one that we haven't really touched on yet. I don't have to do anything in grams or molecules, but I do have to go from mole to mole. So how do I do that? It's actually not too difficult. Okay. So I need to find my mole to mole conversion factor. So it looks like this hydrogen has a 3 out front. So 3 moles of H2 are equal to how many moles of nitrogen? Well, it doesn't have anything, so we assume 1. So are equal to 1 mole of N2. And that's all I need for this problem. This is basic stoichiometry. Okay, so let's start using dimensional analysis. So we say, all right, well, I start with 2 moles of N2, and I'm trying to get 2 moles of H2. So I'm going to use my unit cancellation. So, okay, moles N2 up here, so I want it down here. So it looks like up here it's telling me 1 mole of N2 is equal to 3 moles of H2. And that's all I have to do, because look at that, I'm in moles of H2. Go through, cancel out my units that are on the top and bottom, and again, I'm in moles of H2, so 2 times 3 ends up being 6, and divided by 1, so that doesn't really matter. So it ends up being 6 moles of H2 are needed if I have 2 moles of N2. And that kind of makes sense, because if we look up at our problem, it says, well, 1 mole of N2 requires 3 moles of H2, so if I double my N2, well, yeah, I double my H2 as well. But notice we've used a mole-to-mole conversion factor, right? We used this little guy to go from moles of one substance that we were given to moles of another. This is what we'll be doing in stoichiometry. We'll use mole-to-mole conversions, and we're going to be given either grams or molecules or moles of one substance. We'll convert that substance to moles, and then we can use this nice conversion factor to go from moles of one substance to the other. And of course, once we're in moles of a substance, we can go to grams or molecules very easily. Okay, let's do a more challenging problem. This question here is more of like what you'll see on our quiz. So use the following equation: 2 NaOH, so 2 moles of NaOH plus nothing, so let's put a little 1 there, plus 1 mole of H2SO4 produces 2 moles of H2 plus 1 mole of Na2SO4. So let's look at the problem. It's saying how many grams of sodium sulfate. So I'm looking for grams here, and I don't know that. Will be formed if you start with 200 grams of sodium hydroxide and you have an excess amount of sulfuric acid. So I have 200 grams of sodium hydroxide, so 200 grams of that, and I have an excess amount of this. And this is important because if I didn't have an excess amount of this, and and say this ran out before all of this 200 grams reacted, I wouldn't get the full amount of Na2SO4. It's like if you have baking soda and vinegar, and you only have a gram of baking soda and like 200 liters of vinegar, you're not going to produce as much of your product that you could have with that 200 liters of vinegar, because your baking soda is going to run out. So it's important to pay attention to this. It's going to come into the picture a little bit more in the future. But for now, it's saying you have an unlimited amount of this. Doesn't matter. It's not going to affect your reaction at all. So how many grams of Na2SO4 will you have will be produced if you are just basing this off this 200 grams of NaOH reacting. So this is kind of nice. So in this example, we really don't have to look at H2SO4 at all, and we don't really have to look at H2O at all. We're just really looking at these two substances. Okay, now since we didn't start in moles, and I'm starting with 200 grams of sodium hydroxide, we're going to need to use some of these conversions down here, which we already should be pretty good at. So let's see here. I start with 200 grams of NaOH, and what I'm trying to get to is grams of Na2SO4. So way over here, I'm going to have grams of Na2SO, and put a little 4 there. Okay, so if I was just at moles of NaOH, I could skip right to my mole-to-mole conversion. Life would be good, but I'm not. But I will need to do that eventually, because remember, I can't convert from one substance to the other using grams. I have to go through moles. So let's go ahead and find that conversion here. So how many moles of NaOH do I need to produce a certain amount of moles of Na2SO4? Well, let's look. Looks like 2 moles of NaOH, right? That 2. So 2 moles of this are required to produce, well, 1 mole of Na2SO4. This is important. I've already done some of the math. If you don't know how I got these numbers here, just check back at a later video. But this is the molar mass conversion of NaOH. Here, 40 grams per mole. and Na2SO4 ends up being 142. So I start with 200 grams NaOH. My next step is going to be to convert that, and I need to put that into moles first because, again, I have to convert between two substances. So let's go ahead and do it. 40 grams of NaOH are in 1 mole of NaOH. That's nice. That's going to cancel later. All right. And then let's keep going. I'm in moles of NaOH. Nice. I can use my bottom one. So 2 moles NaOH are needed to produce 1 mole of Na2SO4. Going back through, I can start canceling things out, right? Grams NaOH, top and bottom. Mole NaOH, top and bottom. Left with mole Na2SO4. Really close. Now I just need to go from moles to gram. Hey, that's pretty easy. We've done that a million times. So let's go ahead and do that. Let me get a good color here. Do red. So looks like 1 mole of Na2SO4 is equal to 142 grams. And then again, my mole Na2SO4 cancels, and I'm left with grams of Na2SO4, which means I'm done. Now I just have to multiply across the top, multiply across the bottom, and divide my top answer by my bottom answer. All right, let's go ahead and do this. So I take 200, and I multiply that by 1, then by 142. Okay, and I get 28,400. I'll just jot that down over here. So 28,400. Do the same thing on the bottom. So 40 times 2. Hey, that's one doozy. I can do that. 80. So it's going to be 28,400 over 80. Divide the top by the bottom. And I end up with an answer of, you guessed it, 355. So 355. And 355 what? Well, what was my unit? Grams of Na2SO4. So my final answer here is 355 grams of Na2SO4 will be produced if I react 200 grams of NaOH with an unlimited amount of H2SO4. All right, at this point, I'm hoping you guys are starting to connect the dots. And I'm going to go ahead and give you one more problem. And you can work on this. And then I'm going to write the answer in about 5 seconds. So go ahead, pause the video. Remember, write out all your conversion factors. Make sure you convert to moles, and then do your mole-to-mole conversion. Use dimensional analysis. Good luck. If you're plus or minus 2 or 3 on this, that's fine. Just do it rounding. All right, hopefully you got it. We'll see ya on the flip side.